Hey folks, thanks for watching my video. At the end of this video, I'm going to show you where you can get some extra help. I can't guarantee that when I do these videos, I'm going to cover everything you need. So that's why I'm counting on you as I walk around class and I check in with you. Are you doing okay? I'm not trying to hassle you. I'm trying to see if, my notes made sense. And so if you have the energy at the end of the video, watch as I go to this, kind of extra example online. Okay. If you're like, hey, I get it, I'm going to be okay. Don't watch the very end of the video. All right. So what we're going to do today is a little bit different structure. I want to explain it before we get going. I'm going to talk a little bit about similarity, and then you're going to put the video on pause, and you're going to put problem number 1 right here. Okay. And then I'm going to go get problem number 1. I'm going to paste it there, and we're going to try it together. And then we'll do that with number 6, and then we'll do that with number 11. Okay. So let's go back here and let's get going. All right. So what do we got going on with similarity? Similarity, they're going to tell us two figures are similar by using this little symbol right in there. See that little squiggle mark? It means that the two figures are similar to each other. That means that some kind of enlargement or reduction has happened between this one and this one. Now, it's not real clear which one the original one is and which one the image is. It probably doesn't really matter, but I'll call this one the original one, and then this one the image. On this problem, it probably doesn't really matter. I think usually on the left is the original one, and then this is the image over here, and it will be important down the road, but for now, I don't think it's that critical. So use the similarity statement. What does that mean? Well, it means that angle A, is the same exact measure as angle P. So the measure of angle A is equal to the measure of angle P. And this is how the homework starts out. They just want you to match up first letter with first letter over here, second letter with second letter over here, third with third, fourth letter with fourth letter. Okay, so I'll go through and put a couple more down. Angle B is the same thing as the measure of angle Q. And keep listening, ladies and gentlemen. Don't tune me out, because there's something important coming up here. The measure of angle R. Okay, so I guess I'll finish it off. What the heck? The measure of angle D is the same as measure of angle S. All right. So what's difficult about that? Well, if you look at the drawing, let me grab this drawing over here. Angle A is the same as angle P. So they're not oriented the same way, and the author is doing this on purpose to us to make us kind of struggle a little bit, or at least use the similarity statement instead of just looking over here and matching up the location. But now that I've rotated it, the figure is similar to the figure over here in the same orientation. So now we could say, hey, A is equal to P, B is equal to Q, C is equal to R, D is equal to S, right? But that's not the way it initially started out. So you got to be super careful. When they give you the drawing, you can't go by just, the location alone, or by the, what am I trying to say? The appearance. You can't go by the appearance alone. You've got to go by what the statement is over here. What does it mean about the sides? The sides are in the same ratio. Now let me rotate this thing back over so that we can just go by the kind of the locations. And so I would say, now that we've oriented it correctly, that this side to this side right over here. So AB, if you match it up with PQ, or better yet, I'm having second thoughts about setting it up like this. Let me change it the way that we had it yesterday. We took the image, right, PQ, we took the image divided by the pre-image. And that is called the scale factor, right? This is called the scale factor. And it has to be the same. If the two figures are similar to each other, that scale factor has to be the same for all the corresponding parts. So that ratio right there has to be the same as the ratio for QR to BC. That ratio has to be the same. You could hear me kind of take a big sigh there. I start feeling stressed that I'm making this clear. And if you ever feel stressed that, man, I'm not getting it, I want you to do that. Take a big deep breath and let it out. Okay. And then over here, we got SR, that side right there, corresponds with what's in the same location now that I've rotated around, DC, right? And if you ever lose track, did I rotate it correctly? What you can do is you could say, hey, the third and fourth letters have to match up with the third and the fourth letters over here, right? So let's take a look how I did that. SR, so the third and the fourth letter. It doesn't matter if I say SR, RS, right? And then I've got DC over here, right? Now, why am I doing this one over that one? Because I'm calling this the image and that one the pre-image over there, right? And then the last statement would be our last one here, PS. We haven't done this one yet. And AD or DA, okay? This is the way you do problem number one. Put the video on pause. I want you to try it and see how you do. Now, I'm having second thoughts about me going over and reviewing it after you've tried it because you're going to know whether you get it right or not in McGraw-Hill. So I'm going to skip that part of reviewing it right here. But I do need you to put it on pause before you watch the rest of the video and try this one. I want you to try number 1 through 5, and then number 6 changes a little bit, okay? Hey, thanks for putting the video on pause. Kind of corny, huh? I'm going to go and I'm going to do example 2. The triangle NQP is similar to RST. So I'm going to write that out here. Triangle NQP is similar to RST. RST. That is it. Is it oriented the right way? Let's take a look. NQP, and then we come over here and we go RST. Not exactly, is it? Let me see if I can rotate this guy right here until it is oriented the same way. Okay, so it's going NQP, and we're going over here to RST. Now, let's check one other thing. 12 and a half is a number that's between 11 and a half and 15, right? So 12 and a half is the medium side. So if I go NQP, so I'm going along NQ, then I'm going down to P, then obviously to finish the triangle off, I'd go over to N again. So I'm going medium, smallest side, largest side. Am I doing the same thing if I've oriented it like this? 10 is between 9.2 and 12. Yeah, medium side, smallest side, largest side. So they're definitely oriented the same way now. So it says compare the corresponding angles. Are these, it says determine whether they're similar. They're not telling us they are similar to each other. So let me back up a little bit. I'm assuming, like when I read this first, that they are similar, but we're not sure. So how are we going to determine whether they're definitely similar or not? Well, what did we say up here? All their corresponding angles are congruent, and all the sides are in the same ratio. Okay, so let's check and see if we have all the angles equal. Well, this angle equals that one. Let me change colors. This angle equals that one. Now, why would the third angle have to be equal? Well, we only have 180 degrees to use between all three angles, and we've used the same amount between these two, so the third angles have to be equal to each other, right? So angles, check mark. All the angles are equal to each other. Angles equal, check mark. How about the sides ratios? Well, let's take 10, divided by 12 and a half. So 10 divided by 12 and a half. And then I'm going to go 9.2 divided by 11 and a half, 9.2 divided by 11 and a half. And does that equal 12 divided by 15? Now, there's a couple different ways of doing this. I can see that 12 over 15 reduces. That's an easy one for me to reduce. And I could say, well, this one right here reduces down to, let's see, 3 goes into there 4 times, 3 goes into here 5 times. So that's definitely 4/5, right? Now I could take a calculator and I could go 9.2 divided by 11.5. I'm going to do it that way. Now that I kind of say that out loud, that might make the most sense. So I'm going to go Desmos, and I'm going to go 9.2 divided by, now I got to make sure I get the right numbers, 11.5, right? So I got to divide it by 11.5. Now it's going to convert it to a decimal, 0.8, right? Is 0.8 the same thing as 4/5? Yes, that's 0.8. This one's 0.8. Now we're going to do one more, 10 divided by 12 and a half. Now, if you're like, come on, Nelson, there's got to be a way to do it without a calculator. Yeah, there is. I could make this 100 all over 125, right? Multiply the numerator and the denominator by 10. I still have the same fraction, right? And then I could reduce this. 25 goes into this 4 times. 25 goes into this 5 times. So check mark. I've got the same ratio between all the corresponding sides. So they're definitely similar to each other. All right. Put the video on pause. I want you to try number 6. All right, thanks. Welcome back. I hope 6 went well for you. You're going to work up to number 11. Okay, so if you didn't go up to number 11, sorry, I didn't make that clear. Work on 7, 8, 9, 10, and then we'll do 11. Okay, so if you need to put the video back on pause, do that right now. All right, so now they are telling us the two figures are similar. Back up here, we were supposed to determine whether the two figures were similar. So I oriented them the correct way, but I still wasn't guaranteed that they were similar to each other. We were testing that out. So we tested the sides ratios. We made sure all the angles were equal. Right down here, they're telling us flat out that they are similar to each other. So what we can do is we can skip to this, we can skip to this step right here where we're setting corresponding sides in the same ratio. But we do need to identify what the corresponding sides are. Okay, so JL, well, where the heck is JL? It's right over here. Let me put a little star by it, okay? Is corresponding to QS. So here's QS. Okay, well, that gives me a little bit of information. I know that LM, let me put a little underscore under that, is corresponding with ST. Well, where's LM? LM's over here. Okay, LM is corresponding to ST. So where's ST? Oh, it's up here. So these aren't oriented the same way. I could have probably rotated this. It might have helped us out. So now that I've seen that these two are corresponding sides, I'm going to set them up as a ratio. 3 over 6x minus 3. Okay, it's got to be equal to another pair of corresponding sides. Now let's just look at the two sides that have stars on them. Well, we don't know anything about this side, so it's not going to be helpful for me to try to use the 4. This is going to be one of those classic problems where you've got to decide how to set up the equation. And the author's going to give us like enough information to kind of go down the wrong path if we're not careful. So I'm trying to be as careful as I can. Well, the only two sides that are left are this side that's 4 and this side that's 2. And let's see if those are corresponding sides. I'm pretty sure they are. So J is the first letter, M is the third letter, Q is the first letter, T is the third letter, right? So here's QT, I'll put it in red. And then here's JM. Now I've got to make sure I go 2 over 4 because I went 3 over 6x minus 3, right? So let me kind of make note of that. Since I went 3 over that one, I've got to go 2 over that one. Otherwise, I'm going to get totally messed up. So I'm going to put 2 over 4. Well, that's nice. That's a nice little fraction. That comes down. I always reduce my fractions before doing anything else. It comes down to 1/2, right? And this is 3 over 6x minus 3. Now what I'm going to do is I'm going to multiply both sides by 2, and I'm going to multiply both sides by 6x minus 3. You might also know that as cross multiply. So I'm going to take 6x minus 3 times 1 times 6x minus 3, and I'm going to take 2 times 3. So I'm just going to write 2 times 3. I know you know that's 6, but I'm just going to put it down in case somebody's putting down notes and they're, oh, son of a biscuit. It's 2 times 3, and then I said 6, and I wrote a 6 there. 2 times 3. 2 times 3 is 6, okay? We got that. 1 times 6x is 6x. 1 times negative 3 is negative 3 of that 1. Didn't change anything, did it? Now I'm going to add 3 to both sides, right? Plus 3 here, plus 3 there. I get 9 equals 6x. I divide by 6. This makes me nervous. You know, like, did they give me one where the x, comes out to be a fraction, right? So when I divide by 6, I get 1.5. Okay, now I gotta make sure I'm finding what they want me to find. X is 1.6. I mean, it's 1.5. X is 1.5. Yeah, that's definitely what I'm trying to find, right? I'm not trying to find a side length. They asked me to find X. I'm done. Now, on the test, we've kind of got suckered into that. We found our X. We got all excited. We left that as our answer. Some of us did. And we didn't read the problem carefully. Like if it would have said, let's find LM, we'd have to take the 1.5 and plug it in for X right there, right? So, hey, thanks for watching my video. I'm going to show you where this example is online right now in case you're like, man, that didn't make any sense, Nelson. I'm absent so often. I need more help than just what's in your video. But I do want you to try number 11, see if you can get that right. So right now I'm zooming over to our textbook, and I'm going to my course, okay? And then I'm going to navigate to 3.2. So here's 3. And then I got to get to section 2. We're in similar polygons right now. And then what I would do is I would go to launch presentation. I think you got that same button in the upper right corner. And once the presentation gets launched, I would open the tray down here and I would look for example 2 or extra example. Let's see, where is it? Oh, let me switch back over to my notes here. See, it says check. This was, oh, I didn't make a little copy, but extra example online. Now, there's quite often several of them. So there's extra example 2. There's extra example 3. I'm just going to take a guess and see if it's extra example 3. I should have made a copy in my picture. But they're going to show you how to do the problem and they'll walk us through. So this one's a little different, right? It wasn't the X, we're finding a Y value here. So, but it is the same concept. You've got to match up the correct corresponding sides in a ratio and then do the work. And then right down here, here's the cool part. It says, do you need some extra help doing a problem like this? And so if you click on it, it's going to show you a little video on how to do this kind of problem, okay, from some other teacher, not my video. So I hope that's helpful, everybody. Thanks for watching my video. Good luck on the homework. I'm walking around. I want to help you out.